Okay, so today we're going to be looking at a problem where we're going to be looking at how to find delta H, or also known as the enthalpy in kilojoules moles, based off of our limiting reactant. So if we look at the problem here, it says that 50 milliliters of 0.987 molarity of sulfuric acid H2SO4 is added to 25 milliliters of 2.00 M NaOH sodium hydroxide at 25 degrees Celsius in a coffee cup calorimeter. The temperature of the aqueous solution increases to 33.9 degrees Celsius. Calculate delta H in kilojoules per mole of the limiting reactant. The specific heat is 4.184 joules per gram Celsius. Density is 1.00 grams per milliliter, and the calorimeter absorbs a negligible amount of heat. So, starting off, we just want to write out just our formula in general. So we're given, first off, we're given sulfuric acid, which is H2SO4. It says it's added to NaOH. What we're going to do, we're just going to draw that out on this side. So we're going to use the inside-outside rule. We're then going to have Na2, and then we'll put our sulfate there. And then we have that. Now, what we need to remember is it says that it is an aqueous solution, so we can go ahead and just write that all of these AQ are going to be aqueous. Now that we have determined that it's going to be aqueous, we're going to make sure that both sides are balanced. Now notice there are 4 hydrogens on the product side, but only 2 on the reactants. So we're just going to add a 2 here in order for it to be balanced. Now, when we're looking at this, we first want to find Q being the heat. Now, Q is going to be Q of the solution. It's going to equal negative mass of the solution minus C of the solution, and then we have delta T, also just kind of known as MCAT, since we have mass, C, and then the triangle in delta T, which kind of looks like an A, so that's where you get the MCAT. So once we plug in, just a quick note on the side, we know that the M of the solution is just going to be equal to 50.00 plus 25.00. Oh, I messed up there. You see, we have 50 milliliters, and then we're given 25 milliliters. So once we add those two together, we'll have our volume there. And then we're going to multiply this by 1 gram. That way we're able to get the weight milliliters, which is just going to equal 75 grams. Okay, and then we also need to find delta T. So delta T is just equal to temperature final minus temperature of the initial. You shift it over, so delta T in this case is equal to our final is 33.9, because you see it starts off at 25. Where is it? At 25 Celsius in a coffee cup calorimeter. The temperature of the aqueous solution increases to 33.9. So that tells us that's our final. And then we subtract 25.0. Then we're going to get 8.9 degrees Celsius. Make sure you add the degrees Celsius in chemistry. I know Professor K is always saying units. Okay, so now we've gotten that. Now we can plug that back into our Q solution of MCAT. So just to, so it's negative M solution, then it's what is it, times the C times delta T. So we have this, it should be Q is the solution equals negative our mass, which was 75.0 grams, times C, which is always the specific heat, so that would be 4.184 joules per gram Celsius, times our delta T, change in temperature, which is 8.9, which when we do all that is going to give us negative, remember there's a negative here, so it's going to be multiplied to this answer, and then a positive times a negative is going to equal a negative. It's going to get negative 2.8 times 10 to the third power joules. Now that is our QXN. Now what we need to do is find the enthalpy, which is equal to Q the reaction over moles of the limiting reagent. Now we know that Q of the reaction is equal to negative 2.8 times 10 to the third power joules, but we need to find the limiting reactant. So we have our denominator, because we have our numerator but we're missing our denominator. So what we're going to do to the side is we're going to take our sulfuric acid, so H2, actually come down here so I can have more space. I'm going to do the H2SO4, just so we label that. We have 50 milliliters of that. We're going to multiply that by 1,000 milliliters equaling 1 liter, because when we want volume, just a little side note, it's going to be liters. So that's what we're doing right here. This dimensional analysis, we're getting the milliliters to liters. We're going to do that, and then what we're going to do is we're going to multiply it by our moles, which are given is 9.87. Okay, so times here. Now you put 1 liter is now going to equal 0.987 moles, and then I'll write of H2SO4. I just put that just so that we know where we are and so we don't get lost. And once you plugged it in, that should get you 0.0494. Sorry, 0.0494 moles of H2SO4, sulfuric acid. Now we're going to do the same thing, but now we're going to do it for our nitrogen hydroxide. So we're also just going to write the nitrogen hydroxide formula, and then this time we know that we are given let me see here. Oh, I'm sorry, I messed up a step. Okay, so now we have this, but now we are not completely done. Now we're going to take the moles of H2SO4. So we're going to take 0.0494 moles of H2SO4. We're going to multiply that by the mole ratio. So we know that there's, if we look here, 1 mole of H2SO4 compared to 2 moles of nitrogen hydroxide. Which that will give us 0.0987 moles of NaOH needed. Now we're just going to look at both of them. Okay. We're going to see that this is our limiting reagent, since this is the smaller number. So now we can come back to this formula, which was delta H, which equals heat of the reaction over moles of the limiting reagent. Since you plug in, now we have negative 2.8 times 10 to the third divided by, let me get my numbers here. I have it written to the side, so I worked this out, so I'm reading it also. So 0.05, yeah, moles. And you should get negative 56,000 joules per mole. Okay, now that is our answer. But something that we also have to do is we also have to do the 25 milliliters, that is where I messed up. So you see, that's a mistake that most students, including myself, which I just did, is that we'll go, oh, okay, here, but no, I actually forgot to do the second half. So what it should be, so it should also be 25 milliliters, and we do the same thing times 1,000, so we get liters. 1 liter times liter to 2 moles of NaOH, which got us 0.0500 moles, which is how we were able to get this number right here. Let me just write that. 0.0500 moles. And now this will be our final answer. Negative 56,000 joules per mole. And that is how you find the enthalpy, or delta H, of kilojoule moles when using the limiting reactant. Thanks, and gig 'em.